Okay, so I'm going to start this January 2017 Regents, the one that was most recently given. And we'll start out with number 1. Relative to the graph of y equals 3 sine x, what is the shift of the graph? So here's really the parent function. This is occurring, the 3 is the same. This is occurring within the function, so it's horizontal. And it's a plus, so it's a shift. So because it's horizontal, up and down are out. And then because it's plus pi over 3, it's actually to the left pi over 3. And that's otherwise known as your phase shift. Okay, a rabbit population doubles every 4 weeks. So this is immediately our formula that we should have memorized. Okay, if the rabbit population doubles every 4 weeks, we don't know what the starting amount is and what the ending amount is, but we could make up something. Oh, no, we do. I'm sorry. There are currently 5 rabbits. So that's our starting value of 5 rabbits. It's doubling, so the rate of increase is a 100% increase. 100% as a decimal is 1. And it's happening every 4 weeks. That's where our P comes into play. So I'm going to put this over 4 weeks. If T represents time, also in weeks, so that's good, so these are consistent. And P of T is the population of rabbits with respect to time, about how many rabbits will there be in 98 days. Now, I cannot plug in 98, because that is supposed to be in weeks, like this is in weeks, and like T is in weeks. So for 98 days, I first want to change that into weeks by dividing by 7 days. 98 divided by 7 is 14 weeks. So I'm just going to plug in a 14. So it's going to be 5, 1 plus 1 to the 14 over 4. And 5 parentheses times 1 plus 1 raised to the 14 divided by 4 power gives me 56.5685. About how many rabbits? The closest one by far is the 56. When factored completely, factoring should always start with the GCF. Now, lots of times we don't have a GCF, but we do here. These all have an m. So I'm first going to factor out an m. I'm left with m to the 4th plus m squared minus 6. Now, when I'm left with a trinomial, I should try the guess and check method. And m to the 4th is m squared times m squared. Negative 6, I can try a couple things, 3 and 2 for 1. If I want it to be a positive m squared, I would want the positive 3 and the minus 2. So that gives me m to the 4th, just to check. M to the 4th is good. Minus 2m squared plus 3m squared will make positive 1m squared, and positive 3 times negative 2 will make negative 6. So that worked out, and that's this one. If we weren't great at factoring, we could always kind of look at first of all, the GCF. Hopefully we all can take that out first, and then narrow it down to 3 and 4. But we could just kind of guess or check this answer and see if it worked, and of course it does. Okay? Now, this is a theorem that we have, and actually we should put this on the back of a flashcard. Sine squared x plus cosine squared x equals 1. That's the Pythagorean identity. So as far as filling in what m is here, it's got to be the same x value that one is if it's going to equal 1. So if that's 32 degrees, this also needs to be 32 degrees. I'm going to put a little star there because I got to make a flashcard on that property. That property doesn't come up often, but clearly it did there, and that was the whole question. What is the solution to the system of equations y equals 3x minus 2, which is a line, we don't see it, and y equals g of x, which we do see? Okay, well 3x minus 2, is y equals mx plus b. The b is negative 2, so our y-intercept is at negative 2. And then we rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. I think by this point we will eventually hit the graph again. It's just where that's going to happen. The clear spot that it happens is 1, 1. So we've got that, and actually the only one that has 1, 1 as an option is option 4, so we don't even need to get all the way to that next one. Which statement about statistical analysis is false? Okay? Experiments can suggest patterns. Anything can suggest a pattern, so that is true. And 4 as well. Observational studies can suggest patterns. True. Okay? Experiments can determine cause and effect versus observational studies can determine cause and effect. And unfortunately, with observational studies, we don't control everything. So there could be some coincidental things happening that make it seem like it's a cause and effect relationship when really there's other variables at work. Versus an experiment, we can really make 2 treatment groups exactly the same and make the only difference one condition, and then it's much easier to say that that condition was the cause. So this one is also true. Experiments can determine cause and effect. Observational studies cannot, so that one is false. All right. This is an exponent rule type question, turns into radicals at the end, but we like exponents, so we want to keep everything at first in exponential form. You might want to simplify here first, common basis, 2 minus a third. That's going to be 6/3 minus 1/3, which is 5/3. Then you may want to do power to power, which is multiply, and multiplying fractions is fairly straightforward. 5 times -1 is -5. 3 times 2 is 6. We have a negative exponent, so this whole base needs to be moved to the denominator with a positive exponent. And then this just turns into our denominator becomes the root. So the 6th root of m to the 5th, and that 5 can go in the radical or outside, and our answer then is pretty clearly 2. Inverse function, okay? Switch the x and the y and solve for y. Now, solving a log equation, you have to know your translation as well. So it's your base of 3 raised to the other side x equals y. And so in just knowing that, y is already all by itself and your inverse is already written. Okay, a good old stats question. So this is going to be a bunch of reading. Gabriel performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants are planted without mulch. So the question is with or without. He observed that the average weight of the tomatoes from tomato plants grown in the mulch was 5 ounces greater than those from the plants without the mulch. To determine if that observed difference is statistically significant, he re-randomized the tomato groups 100 times to study these random differences in the mean weights. Okay, anytime you have a simulation, you want to take your result or your observed difference and see where it falls on the graph. So, and it doesn't tell us whether to do mulch minus no mulch or no mulch minus mulch. So I'm just going to do mulch minus no mulch, and we got that the mulch was 5 ounces greater, so the difference was 5. If you place 5 on your graph, it's somewhere in there. So all of these simulations out of the 100 that were done were coincidentally this high. So given that your number falls in the middle of the graph, sort of here, kind of if you made up your 95th percentile, if you're anywhere in the middle there, then this is probably not significant. If it's on the outskirts, though, that's when your 5 becomes significant, because this is telling us right here that that 5 happened by chance a whole bunch of times, if not even more extreme. So there was no effect observed. That's a lie. We definitely observed an effect. We just have to decide if it's a causation sort of thing. There was an effect observed that could be due to the random assignment of plants to the groups. That's the case. We observed this effect, but because it was kind of in the meat of our graph, it could have been just coincidentally how they were grouped. So that's the answer. number 10. So we have a function, a times b to the x power, that's an exponential function, and another exponential function, c times d to the x. When you multiply them, so I'm taking a times b to the x times c times d to the x. I'm going to rearrange it looks like, so to the x powers, and it's multiplication, so I can just kind of rearrange it any way I want. So there's definitely an AC out in front, no surprise there. They all have that. But b to the x times d to the x is not the same as this, because we don't distribute an exponent to a binomial, so that's out. And it's also not this one. We don't distribute a 2x to a binomial. But we can distribute an x to a monomial, and b times d qualifies as a monomial. So b to the x, d to the x. This one would be b to the x squared, d to the x squared, which is not the case. So that is option 3. A little bit different than anything we've seen before, but just a basic exponent rule type of question is what they're getting at. Coming up with a solution to a quadratic. All your answers have imaginaries, so being a quadratic, I'm assuming it's got to be a quadratic formula type of question. Before plugging in such large numbers to the quadratic formula, though, you want to check and see if maybe they're all divisible by something, and I believe these are all divisible by, not 6, because 87 throws that off, but definitely a 3. If I divide everything by 3 on both sides, that's going to turn it into 6x squared minus 8x plus 29, and now my numbers are at least a little bit smaller. If you don't know your quadratic formula, it is on your reference sheet, okay? So it's negative b, so b is negative 8. So we want the opposite of negative 8, which is 8, plus or minus the square root of our discriminant, which is b squared, and b squared is 64, always a positive number, minus 4 times a times c, all over 2 times our a value. 2 times 6 is 12. So if you come up with that discriminant on your calculator, 64 minus 4 times 6 times 29, you get negative 632. That explains the I, right? Because if our discriminant is negative, we get 2 imaginary solutions, all over 12. Now we have to break down 632. So you've got to find a perfect square that goes into it. Just looking at my answers, I'm going to guess that the perfect square that goes into it is 36, since both of these have a 6 pulled out. So if I check that, 632 divided by 36, ooh, no. Did I do that right? B squared minus 4AC. Yep. Alright, so does 16 go into it? I'm looking for a perfect square that goes into 632. No. Does 4 go into it? 4 goes in 158 times. So this is the same thing as root 4 root 158 plus the root of the negative. So that is a 2 pulled out in front. An I for the negative pulled out in front. And then root 158 all divided by 12. And then just both terms can get reduced by 12. So 8/12 becomes 2/3, and 2 over 12 becomes 1/6 I root 158. And we are done. The answer is 4. On 12, we've got a function that's rational and a function that's a log, are graphed on the same set of axes, which coordinates best approximates their point of intersection. So this is just a system calculator. So 2 divided by, make sure in your fraction denominator you keep the x plus 2 in parentheses. That'll give you the wrong answer if you don't. And then we have the log of x plus 1 plus 3. Zoom 6 standard to start, that resets negative 10 to 10. So there's our rational. Let's see if our log crosses that at all. It sure does right there. So I'm going to do second trace, option 5 intersect, and then scroll to that location on my rational, and scroll to that location, which my cursor already is on the log equation, and I get negative 0.9 and 1.9. Negative 0.9 and 1.9 is 86 would go to 9, so that's option 2. 13, the price of a postage stamp in the years since the end of World War I. Price, years are going up, price is going up. The equation that best models the price in cents of a postage stamp. Now, to me, that looks exponential. So, exponential growth. This is linear, that's out. This is exponential, this is exponential, so we'll talk about those. And this is a sine curve, and there's nothing sine about this. So when we have y equals a times b to the x on our flashcards, we're supposed to know that that is your y-intercept. So if you take a peek at that, is our y-intercept 1.04 or 1.43? Now, that's really hard to tell. Really hard to tell. So I'm going to say it's not enough to differentiate. And then our b is our multiplier. So this one indicates that it's increasing by 43% in price each year. And this one indicates that it's increasing by 4% in price each year. Well, I think that 43% growth year by year, as far as the price of a stamp, seems a little bit high. But I'm going to do this just to check. I would guess 3 just based on my gut, but to be sure that it's not increasing by 43%, I'm going to graph this 1.04 times 1.43 raised to the x power. And I'm going to set my window to be exactly what I see here. So my x-axis goes from 0 to 100, and my y-axis goes from negative 10 to 60. And if I take a peek at that, is that exactly what that looks like? Absolutely not. This one, the increasing by 43% is causing this to shoot up so much faster. And just to doubly confirm, I'm going to go to 1.43 and 1.04. And again, I still already have my window set. And is this one a better match for the graph? And 100% it is. All right. The 8th and 10th term of a sequence are 64 and 100. So 64 is your 8th term. Your 9th we don't know, but your 10th is 100. Now if it's arithmetic, we're adding the same thing every time. If it's geometric, we're multiplying by the same thing every time. So what can the term not be? Now we have, again, on our reference sheet, a lot of these haven't come up yet, but we have arithmetic sequence and geometric sequence. And remember, even though these have 1s there, we can do a sub k. So we don't have to know the first term and the nth term. We could know 2 terms, and in this case, the 8th and the 10th would be fine. So I'm going to treat this as arithmetic at first. And instead of a sub 1, I'm going to do a sub k. And, oops. It's n minus k times d. So my nth term is 100. My kth term is 64. My n actually is 10 and my k is 8. And I'm solving for the common difference. So I'll subtract the 64 over. This is 2d, and d equals 18. So if this is arithmetic, then I would add 18, and 64 plus 18 would put this at 82. So it could be 82, and this is asking which one can it not be. So we know it could be 82. I'm also going to do the same thing with the geometric. Again, I'm not going to use a sub 1. I'm going to use a sub k, r to the n minus k. So again, the nth term is 100. The kth term is 64. My r is what I don't know, but my n minus k is 10 minus 8. So I would solve for r. I divide by 64. 100 divided by 64 gives us 1.5625 equals r squared. We square root both sides, and r equals, r could be a positive or negative. The square root of that 1.5625 is 1.25. So if I multiply by positive 1.25, that puts me at 80. and then 80 times 1.25, just to show you, brings me to the 100. So if it's times 1.25 times 1.25, this would be 80. So 80 could be in the running. But also my rate could be a negative, so if I do 64 times a negative 1.25, my term would be a negative 80. And then when I multiply by negative 1.25, again, I'd be at 100. So it could be negative 80, so the only one it can't be is 1. Okay, 15 gives us the loudness of sound measured in units called decibels. These units are measured by first assigning an intensity to a very soft sound that is called the threshold sound. The sound to be measured is assigned an intensity, and the decibel rating D, so intensity is I, decibel rating is D, the threshold sound is I sub 0, and then we obviously have an equation. The threshold sound audible to the average person is this. All right. So consider the following sound level classifications. A lot of reading, figuring out your variables. How would a sound intensity, so sound with intensity of this, be classified? So they're giving us the threshold sound audible to the average person. Okay, so this is the intensity. So if I go back up to my formula, this is the intensity I. So D equals 10 times the log of 6.3 times 10 to the negative third over I sub 0. How would it be classified? So we need the decibels, so we need the D, and all we really need now is the I sub 0, which they have told us is the threshold sound is 1.0 times 10 to the negative 12. So we just need to type this, just more reading than anything else. It might take us reading 3 or 4 times before we wrap our head around that and plugging in the variables for what they say. But just typing that into your calculator, you want, on the numerator, you can actually do, you need your numerator to be 6.3 times 10 to the negative third divided by your denominator needs to be in parentheses 1 times 10 to the negative 12, and you're going to get 97.99. So just categorize that. That's in very loud, and so we would circle very loud. I'm going to stop there, but that's only because I'm out of time for the moment, and I will come back and finish the rest in another video.